Hi, we are Team Infinity, and myself, I am Arvind Kuganandan, where my teammates are Shashikiran Hekti and Dhanush Nivasa. I am here to give you a demo about multi-feature classification of RNA dataset. Before moving towards the detail of the project, we know that cancer is one of the most important diseases that can occur to human beings. The earlier we predict the cancer, the better the outcomes are, and the better the chances of survival. So our model here is to um, take uh, take take the RNA dataset from a from a portal named GDC where it maintains all the cancer related dataset, and we are going to do multi-feature classification by by using certain algorithms and in order to predict the cancer at as early as possible. So before moving to the project, let me show you a small animation clip where which recites the analogy of our project. So now we see here a hospital setup where a patient now comes in and he moves into the receptionist. The receptionist now guides him to the laboratory to state his details. Meanwhile, the other patients are now queuing up in the hospital to meet the for their appointments. And the receptionist now we see has guided him to the laboratory. The patient, meanwhile, goes to the lab and now submits his report to the lab technician for his diagnosis. So the lab technician starts to analyze his data. Meanwhile, we can observe the other patients who have been queued up also have given their details, and as a result, the cancer database is huge, and there is a possibility that a human might make error. So she's now telling that there is no cancer for this particular patient. So she's given a wrong prediction. The guy starts to lead a normal life, and he doesn't take a long treatment, and as a result, he dies due to this. This is the common fatal error. So now in our model, the emphasis is to provide the history of our RNA patterns and data sets so that we can predict the cancer at as early stage as possible, so that the chances of survival becomes more high, as well as the doctors can easily predict the cancer. Now I'll hand over the presentation to Shashi Kiran Hegde, where he'll give you the overview of the project, as well as he'll give you a small analysis of what our model is gonna do.
Thank you, Arvind. So, as you have seen in the analogy, it's human tendency to make errors while analyzing large data sets, and these minute errors might impact the well-being of patients on a larger scale. Now, let's look at different stages of cancer and the survival rate associated with them. Stage 1 means that the cancer has just begun and it is concentrated only at one part of the body. Survival rate is 94% for this stage. Stage 2 and stage 3 represents that the cancer has spread to nearby tissues from the point of origin, and the survival rate reduces to 82% for stage 2 and 67% for stage 3. Stage 4 means that the cancer has spread across the body, and the survival rate is a very low 11%. So, if we are able to predict cancer with great accuracy, we will be able to save a lot of lives. In the olden days, scientists used to take 18 to 20 years to predict cancer. Due to the advancement of medical technology and the upcoming of different machine learning algorithms, people are now able to predict cancer better, and half of all patients survive 10 years or more after the onset of cancer in recent years. Coming to the cost analysis of cancer, you can see that the cost in the initial phase of cancer treatment is lower than the continuing phase. In the last phase, the cost decreases, but the survival rate is also very low in the last phase. So, for example, if a doctor predicts cancer wrongly, the patient has to undergo a lot of treatment, in turn spending a lot of money, only to realize later that he or she does not have cancer. In the other way, if the doctor does not predict correctly that the patient would get cancer, and if the patient realizes at the end that he or she has cancer, he or she might be in the last stage and the survival rate is very low that he or she might die. So prediction of cancer is very important in terms of both cutting down on costs and saving people's lives. The abstract overview of our approach is that we take RNA sequence from GDC portal, we pass it through our model, we do pre-processing, clustering and filtering, and in the end our model predicts if a person would get cancer or not.
Thank you, Shashi. Now I'll be going through the technical part of our project. First, let me provide you with an abstract view of what we are doing for the project. So we downloaded the RNA dataset from the GDC portal where the data was in gigabytes. So we had to do some pre-processing. A quick analysis of the data showed 11,000 samples with 65,000 plus classes or features. Since the dataset was too big to be processed on a general purpose computer, we uploaded the data to the cloud and used Amazon AWS services to run most of the initial part of the feature selection. After feature selection, we trained a classic ML model to fit the reduced data for better prediction. Now let's dive deeper into the technical overview of the model. We know most ML models have a basic flow of feature reduction using PCA or other feature reduction algorithms, and then followed by classic ML. However, to make our project somewhat unique, we do feature selection using supervised and unsupervised algorithms and take the intersection of those features for better feature selection. Initially, we divide the gene pool and give them to the two feature reduction models. In our case, we have k-means as an unsupervised classifier and LDA as a supervised classifier. These two provide some metrics for each feature. We then softmax the feature and rank them based on the ranks. We select certain features. As you can see, the number of features have reduced from 65,000 to around 28. And in the end, we apply classic ML to get better and faster convergence. As far as the results are concerned, we were able to get an accuracy of 93% with a model and a convergence time of around 5 minutes. The same with just k-means, where we had the number of features reduced to 2141, the accuracy was around 80.77% and a convergence time of around 30 plus minutes. With just the raw data, we ran the ML, we were not able to converge even after 2 hours. If we compare our result with some of the other implementation, link provided in the reference section, we can see a better accuracy with a model, where the model in the implementation has an accuracy of around 86%, whereas our model has an accuracy of 93%. Also, we are able to classify around 28 types of cancer with greater precision and accuracy. The same with precision and also accuracy. We also plotted the confusion matrix for our model. The blue diagonal line shows how well the model is able to predict the values. Here are the steps we followed throughout the course of this project. Here are the links to some of the references we used in our project. Thank you.